Hello. Welcome to Google Cloud CI/CD Speed with Security and Compliance. First of all, thank you for coming. If you're still here today, we appreciate it. If this is not the talk you're looking for, oh well. So we'll dive right in. I need the clicker, that's right. I am in charge now. This has a laser pointer, so any inappropriate questions will be responded to. So first of all, your feedback is always greatly appreciated. It's important to us. It helps us make our talks better. There's an app I think you built into it. You can't actually start telling us how great we are for 20 minutes into the session, so you actually have to have watched it a little bit. My name is Michael Windsor. I am the product management lead at Google for Cloud CI/CD. I manage a bunch of products, including Cloud Build and Container Registry and so forth. And with me here today is my friend Dmitri.
Hello, everyone. I'm Dmitri Lerko, and I'm head of DevOps at loveholidays, and we've been using Google Cloud Build quite successfully for last year.
All right. So with that, we're going to dive right in. We will have time for questions at the end of the session, so if you have them, make note or pull them up, we'll take them at the end. So our goals for today. We're going to start just by talking about the challenges of CI/CD, why it's hard, why that's interesting, and what we do about it. We'll then talk about how we see the world of cloud native, what it means to be cloud native, and the principles of cloud native application development. We'll then take a look, a little inventory, if you will, of the CI/CD products and services that are part of GCP. And then we'll try and connect the dots, show how these principles apply in our products. And then finally, we're going to walk through a real-life demo showing you how these things come together so you can understand how you can apply them in your own world. All right. So let's talk about CI/CD. It is hard. It's easy to get started in a simple way, and then things get really messy. And one of the first things that's hard about CI/CD is actually setting it up. Just getting up the system, getting it up, getting hooked up to all your various integrations you need to have, having it reliably run as part of your operation, and then doing it again when somebody else creates another project, or another repo, or another branch, or whatever. And that kind of setup actually gets in the way of doing it the right way. What we've seen a lot is that customers will get something working once, and then just start dumping things into it. That makes it worse every time. Nobody knows what's going on, nobody knows how to fix it, and it becomes this giant little hairball that becomes part of your problem. A few nods on the audience there. I think we all know what we're talking about here. Another interesting thing to talk about is scale. So at its core, CI/CD is actually a compute problem. What you're trying to do is run as many builds and as many tests as early as possible. Right? In a perfect world, we would run every single test and deploy it into every environment with every keystroke by the developer. But we can't. So we make trade-offs about bundling up those changes into commits, into releases, and so forth. But either way, you're going to do a lot of builds. You're going to do a lot of tests, and that is a compute problem. And most of the challenges, once you finish getting this set up, are involved maintaining that scale and keeping it running on a long-term basis. And then finally, in this day of cloud development, I think everybody understands that security isn't the first question, it's not the last question, it's the always question. You always need to be dealing with security. For fun, I would encourage everybody to go off and Google Ken Thompson compiler hack. Ken Thompson was one of the original Unix developers, and he actually hacked the compiler to detect when it was compiling itself and to detect when it was compiling login.c on Unix. And you can imagine how that plays out, right? So the compiler knew how to inject code into itself to handle injecting code into the login prompt so you could have a backdoor into your login system. Now you say, well, that's not what's happening here, Michael. But everybody who has access to or controls your software that is going into your CI/CD system has complete and total access to your production environment. Now it starts to matter. So that's the initial setup. Let's talk about cloud-native applications. So I think cloud-native has seen a proliferation of microservices, which are usually typically using containers. Containers also are letting people use more languages and more runtimes. Once you start packaging your application up into a container, the freedom of choice that your application teams have about which languages, which runtimes, which packages they pull in there creates a proliferation of complexity as well. So now you have more containers again. And then as you do rapid iteration, which is one of the goals, you end up with more builds of more containers with more stuff. Right? Now the scale problem is becoming a little bit more real. So as you expand horizontally with the number of services that you have and vertically doing more tests, right, you end up with an awful lot of CI/CD pipelines. Managing those pipelines becomes a full-time job, and it gets harder to keep it up. Another aspect of sort of cloud-native applications that is generating context here is that a lot of things are declarative. Kubernetes is notably a very declarative system. which is great when you sort of get something going, but then managing its scale and having it work well and knowing what happened and how to handle like that becomes a challenge as well. So the best practices in this space are hard to come by, and scalable solutions even harder to find. We're going to dive in and look a little bit more. Oops, went too fast, double-clicked. Okay, so let's look at some core principles. You'll see a lot of these things. You've probably seen some slides and decks earlier on today, on the previous days. This is just our view onto it. There are a lot of commonalities. First and foremost, everything is code. So everything is code means that we have one source of truth, reproducible from that, about everything in our system. This is what matters the most, right? What is running in production is a really interesting question. If you don't know how to get back to what's in production, you now have a very interesting problem, right? Don't have interesting problems. Containers and microservices. Containers are the atoms of cloud-native computing. They're small, granular units that allow you to scale all kinds of different things, not the least of which is your engineering teams. By having engineering teams work on smaller chunks of code together, you can go faster with less complexity. Until you can't. Right? One of my favorite phrases is you move from monoliths to microservices, and then inevitably you end up with microliths, where you have a complex interchange and network of microservices that have so many complex dependencies that you actually regret not having a monolith again. Right? So being intentional and formal about that is important. Containers are used not just for the runtimes of your application, but also for the tool chains. All the applications that you use to build your application are all part of that and packaged up in containers so that we get a consistent environment. Next principle is serverless. Serverless to me is about, well, don't make me worry about the servers, right? Obviously, there are servers somewhere. From your point of view as a customer, what you want to be in a situation is not thinking about servers, thinking about your problem. Build my stuff for me, run my application for me. But to make that happen, somebody has to do the work for you. And what does serverless mean? It means resource pooling. Take care of having a background of resources to spin something up. Don't make me wait for a server to be provisioned on demand. Have it ready to go for me when I need it. Right? It means rapid elasticity. So when I need more servers, have one ready to go and let me scale from 0 to as many as I want, as quickly as I want. And then, because I want to have my cake and eat it too, what we call measured service. Don't make me pay for things I'm not using. I want to pay only for what I consume, and that's the whole point of this pool. So serverless is really one of the key attributes of scale because you get rid of all the management of those servers. You don't have to keep them up and running, somebody else's job, and you're not paying for things sitting around on the weekend when you're not doing anything. And then back to security, because we'll keep talking about it. You want to have isolation. Security is keeping things separate. Separation of concerns creates a better defense in depth model. You want to have continuous security. Security isn't something you come in and do once a week and check in on. You want every part of your development process to be checking for security and enhancing the security of your applications. And then part of security really is what I call continuous policy and compliance. Right? So security is one thing of like, make sure I don't have things that are leaking and so forth. But security is also a policy problem of making sure that the applications, the services, the way they're getting built, are all being done in a way that I have some control over that fits my business model, my practices, regulatory or otherwise. And then finally, automation. Automation is what lets us go fast. It creates reproducibility by having things work the same way every time. And it gets us go fast because we've got this safety net of being able to run tests automatically no matter how much stuff I keep adding to the code. One of my colleagues at Google likes to talk about scale in a very interesting way. Every single development process you have, every part of your business of building software, will either scale sublinearly or superlinearly with the growth of your product. And by the growth, I mean number of developers, number of check-ins, over time, more features, number of customers. Everything about it causes scale. And then you can look at your processes, whether it's how many tests I can run with each build, how many builds I can do a day. It's either scaling faster than your application is growing or slower. And if it's scaling faster, you're going to run out of headroom and you're going to be able to have to run less tests or do less, and the quality will suffer. Right? And so once you start looking at your process, you're like, okay, automation is my only path here. If I can trade compute and spend more money on compute to get to scaling my process, my application team can keep going as fast as they'd like to go. Now, a fact that we cited many times this past couple of days, the DORA survey that we do on an annual basis, only 29% of the people we talk to are really meeting all 5 of these characteristics in their development process. Right? So that sounds pretty bad. The good news is people are doing some of them, right? And you don't actually have to do them all to be successful, but you do need to start chipping away at these in order to increase your velocity. And why do we care? At the end of the day, this is not about building software, it's about delivering business value more effectively. And again, the DORA reports show how adopting these principles and applying them in your development organizations allow your teams to go faster and to deliver business value to your customers faster. That's the point. So just a quick inventory of how we think about CI/CD and the development process within Google. End-to-end tooling for cloud native starts with Cloud Code. Cloud Code gives you edit, compile, debug for a Kubernetes application in your local environment. It takes care of automatically deploying it to a private cluster just for you to do the testing if you have multiple services. Installs as an IDE plugin for Visual Studio Code and IntelliJ, and is pre-configured with samples for most of our scenarios to get you going quickly. Once you finish editing and compiling and debugging locally, you push it up, you start merging it or integrating into the broader hold, and that's where Cloud Build takes in. All right, it's completely a serverless platform. You can build, test, and deploy your applications into the cloud or any target you want at scale. Container registry is sort of like the file system of a cloud-based development environment. You push your containers up into the registry, and then various other processes, whether it's the runtimes or other build systems or deployment management, can pull those containers and do what they want with them. At the runtime level, things like Kubernetes Engine, GKE, or Cloud Run. GKE is the production-ready environment for running containerized applications on Kubernetes. And Cloud Run is a fully serverless environment for running container-based applications. You just execute one command to deploy your container, and we take care of scaling, load balancing, percent allocation, and so forth. And then finally, once your application is up and running, managing it over time, that's part of what we do through Stackdriver or other monitoring tools with alerting and logging and so forth. So if you think about it, each stage of this process, what we're doing is constantly testing for correctness. So the classic thing, somebody starts writing code in their local environment, and they edit, compile, debug until they think they fixed all the problems, and the code does what they think it does, right? Usually by running tests against the tests that they know are the ones that matter. And then they promote it up to the next level. And what do we do there? We run more tests because they were wrong. We find tests again later on. And we run more tests, we package it up, and then we do our release process. Very few people do release directly from commit. Why? Because we like to look at things and test them in a longer environment, whether it's a staging or testing environment, because we're going to find more problems again. And then when we release it, what do? We do progressive rollouts, where we only put it out to like a small percentage of the users up front. Why? Because we know from experience that we were wrong every step along the way, and there were still problems we hadn't found. And then finally, once it's actually running in production, what do? We watch it constantly, because we were still wrong, there's still something going to go wrong with it, and we need to track that as soon as possible. So every step of the process here is about testing for correctness of your application at different stages of the development lifecycle. Okay, so let's look at how we apply the principles we talked about into those services and products within GCP. So we talked about everything as code. This is the key thing. Cloudbuild.yaml is the build spec for whatever you want us to do, the jobs that are getting done, and run, and that is all specified as a source file in your repo. So everything lives in the repo, and including the tools that you use to build things are also specified in repos and managed that way. So now you have everything is versioned. Think about this when you go back and you want to go back and be able to rebuild a version of the source code at a certain point in time. You can rebuild not just with the source code, but also the environment, the tools, everything all specified in the same space. All right? You get a clear audit. So here's an example of everything as code where the cloudbuild.yaml is driving each of the steps, one build step after the other, and producing output that generates to the next deployment target, including things like Firebase, Cloud Functions, or whatever. You have one source of truth. The foundation of automation and GitOps is putting everything into your source repo through Git, and you get easy rollbacks, easy debugging, and analysis for any version of anything. Right? You'll hear me use the words reproducibility a lot. So let's talk about everything as containers. In Cloud Build, every single build step that does something, whether it's compiling, or testing, or publishing, or deploying, is packaged up as a container. So in some ways, think of it like a shell script, where instead of a command that you type into a line, it's actually a reference to a container that invokes the command. What that does is it creates predictable tool chains, managed well, and isolated environments for running them. We have a rich library of pre-built container images for common build scenarios and test scenarios and deployment, and all the tools that you need. And there's a rich community of library images up on GitHub, which you can contribute to. Everything from like Hugo, the static blog publishing system, to Maven, to Bazel, to compilers and so forth. Last, the container that you produce as part of your output is a first-class citizen in Cloud Build. So you can build anything you want. You can build Android applications. You can compute Pi. Please don't do Bitcoin. But containers are a first-class citizen, so when your output of your build process is a container, Cloud Build has key concepts in there which help us manage it and propagate the identity of that container through your build process from step to step. All right, how am I doing here? Good. Here's just an example, again, of a typical Node.js pipeline in which you pull it out through Git, npm get the packages you want, Docker to compile it into a container, and then kube control to deploy it to your cluster. Right? And if you're pulling your packages live at runtime with the, quote, latest version, you're asking for really interesting things to happen in production. OK, let's talk about serverless. So Cloud Build is serverless. By that I mean, I'm going to go back and say what I said earlier. We manage the worker pool for you. You have no servers. You don't think about servers. You just send us builds, and we do them for you. Right? We keep that pool hot, so we have a VM waiting for your request coming in. Set up the VM, instantiate the container, pull down the repo, and off it to races. Concurrency is built in, so if you have lots of developers doing lots of builds, either in a PR or on demand or whatever they want, we scale up for you. It takes care of it. And back to the points we talked about, measured service, you only pay what you use. You only pay for what you use. And we actually have a pretty generous free tier, so a lot of our early-stage customers don't see a bill at all. They just bill for free. My boss really wishes I had a revenue-generating product, but he's pretty happy about free tiers as well. So this is an example. I skipped a slide. So let's talk about security, how we apply that in Cloud Build. So first thing is, every VM that we use to run a build, right, we actually set up a VM, set up a shared file system within that VM, but it's a fresh VM for every build. When your build is finished, we throw that VM away and then instantiate a new one. And we can do that efficiently because we have a whole pool of them sitting there waiting for the next build to come along. We have vulnerability scanning that is a service that will automatically look at your containers, find all the known vulnerabilities of the operating system packages in that container, provide metadata and alerting for you so you can actually make sure that your containers that are deployed are not vulnerable. GCP has a rich set of services around audit logging, around security. There's a command and security center for things like that, and obviously identity management and just general logging, all of which is fully integrated with Cloud Build. And then finally, sort of in a belt and suspenders solution, binary authorization ensures that only policy compliant, where you define the policy, properly signed containers are deployed to production. Okay? So here's just a quick example of that. Committer creates code, it gets built, vulnerability scanning goes off and makes sure that the container is valid. There's a policy in binary authorization that says only allow for things that are not vulnerable. Those images are trusted and get deployed into Kubernetes, and untrusted images are logged in the audit log and rejected. Right? So this is just one element of the security thing, but it's a great thing. Everybody should be looking at that. And by the way, the pipeline for your CI thing that does deploy is where you can have different permissions, different access control, that specifically make sure that you have policy that is not changeable by the people shoving code through the system. Okay, and then automation. I talked about this a lot. Reproducible builds are key. Let's imagine a scenario where somebody committed something, it's an interesting piece of code, it works out, and 6 weeks later on, you find out that there's some bug in the system, and you're trying to figure out what happened, right? But meanwhile, people have been writing code like crazy, or 17 versions later on, going back and be able to reproduce the build. And there's lots of elements to this, one of which is have a very strong association between the commit and the container ID, right? You want to be able to know that the container is a perfect proxy for the source code, and you want to be able to rebuild that container if you need to at will. So the tool chain, everything about the environment, all being managed in Git, and the clean environments of Cloud Build ensure reproducibility. It's key to observability, it's key to debugging and trust. Automation also means that it's very easy to go off and apply your CI to every branch. I can't tell you how often I've had customers where they've got the manually installed CI system for a couple of branches, and then when somebody sets up a feature branch, they're like, yeah, it'll be okay. Right? Or they're like, I wish we had a better CI for that branch. And then another project, right? And then at some point you realize, well, you shouldn't do that, so don't do that, so you stop creating branches or you stop creating other projects, and now you have a velocity sort of friction on your team. And then we have build concurrency, so you can actually go off and do all the tests that you want, and you can customize the machine types to take the kinds of machines you want to do the bigger tests or high performance tests that you need to do. Right? So again, think about this as horizontal and vertical scaling. Horizontal is adding more builds that happen at the same time, whether it's multiple branches, multiple developers doing PR or whatever. And then vertical is doing more in those builds. It takes longer, they need more capacity to go off and do more testing and validate the correctness of your code. Right? Going back to that point, you'll never get to the point where you're able to run every test with every keystroke, but you should really try to get as close to that as possible. Okay. So with that, I'm going to ask Dmitri to take us through a little bit of like how you're doing this and show us some demos.
Absolutely. Thank you.
Clicker to you.
I'll grab this off you. So we at loveholidays have been using Google Cloud Build for over last year, and we used all of the relevant CI/CD tools in the Google Cloud. And it looks really good for us, and it works really great for us. However, this story will not be complete unless I tell you where did we came from. So if you look back maybe 15 months ago, we as a company been running on-prem. Our only tool of CI/CD was Jenkins. So we had a relatively small team of 20 developers managing 30 core applications. And centrally, Jenkins was performing all the integration builds and all the deployments. But it was full of problems. Problem number one was compute. So we had not enough physical capacity of the servers to build every single commit the developers were producing. So they had to go to Jenkins and select what they want to build. We also had not enough capacity to store all the Docker images and all the jars produced by our builds. Another problem. So instability. We had hardware instability, we had Jenkins instability, and we had instability with actual builds and deployments. Combined together, that was eating half of my day just figuring out what has broken where. And it's not a good place to be. We want to innovate and move faster, not just to keep patching existing system. As I mentioned, it was centralized, but in a bad way. So the system been running for many years even before I came to the company, and it was always wide open. So any developer in the company can come, configure any kind of jobs, any kind of builds, deployments, install plugins. It's free for all, so there are no restrictions. And that's not a good place to be because it creates a lot of inconsistencies, very confusing UI, and Jenkins is really good for make it very easy to add things, but it makes it really difficult to do it in a very consistent manner. Security was a big problem for me because keeping Jenkins itself up to date was not too bad. It was rarely breaking changes, but then you add a plugin, and knowing where this plugin originated from, it's pretty hard because you need to check the supply chain. Now, imagine you have 162 plugins installed on your Jenkins. 162 plugins. That's because everyone could install plugin and it felt like it's a unicorn solution to every single problem. Just add one more plugin and everything is solved. We probably use 30 or 40 of them daily, but it was really hard to get rid of those reminder of them because you couldn't tell what is dependency chain. So it was quite difficult. On top of 162 plugins, we had about 300 jobs and 42 tabs. So what you see on the screen is just one tab. Now multiply it by 42 and imagine there are directories. We had to onboard people on how to use Jenkins, where to find their builds, how to build their branches, how to deploy the development, staging, regression test, production. They clicked the wrong buttons, and we deployed the wrong stuff in the wrong place.
So you had a user manual for your CI/CD system for your team.
We had to write one, yes. Oh. It was not pretty.
Okay.
Luckily, we decided to evolve our system, and first step we did is we decided to diagram it. And when I've been chatting with Michael, he asked me, well, show me what you got. I really want to know to see how I can help. So I started diagramming, and he just stopped me 10 minutes in saying, we'll never fit this on the slide. So what you're seeing currently on the screen is a very, very, very simplified version of what we had. But even now, if you pay attention, you'll see that it's, first of all, complex. There is a lot going on. And biggest problem for me was the manual steps. User has to log into Jenkins, find the right job, perform the right build. And the very same thing with deployments. Again, you need to find the right tab, right job, put the correct hash, and deploy that. It's very, very error-prone, and errors are costly for business and our customers.
So lots of people had access. They had to go in there to do things. They had to do them manually, and you had just the one, the Jenkins. What could
The
possibly go
gold
wrong?
of CI/CD. There have been a lot of things going wrong and spending way too much time on it. Luckily, we haven't stayed still, and about 12 months ago, we migrated the entire company to the Google Cloud, including CI/CD. In fact, Google Cloud Build was the first product we started to migrate to because it allowed us to incrementally move over our build from one system to another and start deploying to the Google Cloud. Therefore, I would like to walk you all through a demo showing a couple of nice features that we at loveholidays use daily to do with Google Cloud Build and relevant cloud-native CI/CD tooling in the Google Cloud. First of all, I'm going to show you how we can perform builds on our local environments. Then we'll integrate with a GitHub, and it will be a full-circle developer's lifecycle. We'll add vulnerability security scanning, so we'll know what sort of known vulnerabilities are in our images. If there are none, we'll deploy this to our development and production Kubernetes clusters. And lastly, I'll showcase you binary authorization. It's a final arbiter that allows me to implement policies that disallow insecure and unproven images to be deployed in any cluster of my choice. So as you can see, I've got a prepared GitHub repository that I'm going to clone. Once again, let's see what's inside of it. So there are two main files of interest. One is Docker file, which is a definition of how to build a Docker image. It contains 2 lines. First line tells me that I'm going to use Nginx Alpine image. So it's Nginx reverse proxy. And second line is that there is an index.html file inside of this image. Super simple, nothing complex about that. I also got a cloud build.yaml. And as Michael mentioned earlier, cloud build is fully declarative. So you write your build steps in the YAML files, and you decide what you want it to do. And every manager of repositories and applications can decide what goes in this file. So in my case, it's rather simple. It has one main build step called build Docker image. Once this image is built, you can see this images parameter. It will ensure that the resulted image is uploaded to the Google Cloud registry, container registry, sorry. So first thing I want to do is to perform build on my local environment. For that, I'm using a tool called Cloud Build Local, which is a part of the Google Cloud Build suite of tools. It allows me to not use cloud and perform build offline just on my laptop using my Docker image, but using the very same primitives as the cloud will do.
So that's running just on your laptop, no connection whatsoever.
Exactly, you can do it on a plane. So
cool.
It's really good if you're trying to maybe make your cloud build YAML a bit more complex, add some logic to it. It's a very quick iterative process of trying it out, various steps without actually pushing anything over the network. Next, I will perform a build using Google Cloud's infrastructure. For that, I'll submit a build using this command, and I'll also point it at cloud build.yaml file. So it will follow exactly the same steps as it just did locally, but it will perform it remotely. As you can see, the first thing it does create a tarball. So it zips together all of the data on my local source folder, pushes it up to the Google Cloud, and there it performs the build following the cloud build.yaml definition. So it has a one-step build Docker image.
That's pretty cool. So you could do that with like a really crappy laptop and no RAM, and you edit locally and then just build it up in the cloud.
You can do it off your phone.
On your phone. Try that.
So the logs you can see in the UI are exactly the same logs that you can see in the console. They both succeeded, and it's your choice whether you like to use a console or whether you like to use UI. Pick any. Given that we built an Nginx reverse proxy, I definitely want to run it and see what's inside. So I'm going to execute it on my local laptop using the previously built image.
Awesome creativity coming here. Hold on. It's gonna be really
Let's
good.
see.
There we go.
Hello, Google Cloud Next. So as you can tell, it's very simple. So we have a local build that produced a Docker image, which only contains Nginx and index.html file. So that should be secure, right?
Sure, right? It's secure.
Nothing to go wrong.
What could possibly go wrong?
OK, moving on.
No product manager should ever ask that question.
So if you go back to the UI and you look at the previous build that I showcased, at the very top, you'll see a URL that goes to the image. So we produced an image, and it got stored in the Google container registry. You see the size of the image and when it was created. And
What is that yellow triangle, Dmitri?
it's not a good news. So it looks like our demo could have been better. Yes. So we got about 35 known vulnerabilities, and some of them are pretty severe. I do not recommend deploying this anywhere at all. Actually, I'm going to delete it from my laptop as soon as I can. But I think we can fix this. So if I go back to the Docker file and apply a sysadmin's best practice, keep all your dependencies up to date, I'm going to bump up the version of Nginx Alpine to latest known to myself, which is 1.16. Do not ask me what I've been doing last 7 versions.
I know, I really want to know.
I kind of missed them. And this time, I will show you how well Google Cloud Build is integrated with the GitHub. So I'll create a new branch and push it out to the GitHub and see builds triggering automatically. So let's do this and push it out. So if I'll refresh my GitHub, we got a new branch. I'll create a pull request. I want to raise it against development. Done. Over here, you could see the commit that I've just made, and a very interesting yellowish circle. So if I click on the circle, it tells me that there is a Google Cloud Build trigger. I can drill down and get all the way back to the Google Cloud console for the Google Cloud Build and see the very same build happening in real time. Actually, it was so fast that it's now completed. Also, if I'll drill down into the image that this build has produced, just to showcase you what I've actually committed to make sure there is no trickery, I've just upgraded the version from 1.9 to 1.16. Going back here, there are no more vulnerabilities. So it's just simply by keeping our versions of OSs up to date and Nginx up to date, we got rid of quite a lot of security risks.
Ship it.
A lot better, right? So exactly, let's try and ship it to development. To do that, I need to go and find my pull request, which is now has a nice green tick box saying that the build has passed. I'm going to merge it in. And have a look at the development branch. So you see yet another yellowish circle. I'm going to click it again, see more details. It's another fully automated triggered Google Cloud Build. As you can see, I have not triggered anything myself, so that's all declarative.
So the first one was a PR build. It ran the build, did the tests,
Exactly.
and then threw everything away.
It just makes sure that you can build the image.
Correct. And then the next one is now a post-commit build that's actually going to go off and do the deployment.
So for development branch, I have a special logic to follow different build steps.
Okay.
And I'm going to showcase them to you now. I'm not sure how did I get here. But demo got.
We've only practiced this 45 times. It worked perfectly every time.
We needed one more.
Love demos on a late day session.
So I believe I'm on the development branch. Let's go to the Google console.
So Dmitri is now sweating about 3 ounces per second. Yeah. I'll entertain you with singing or dancing or just bad jokes if you want. There we go. We found the build in the system.
So as you can see, the last trigger was pushed to development. I'm going to drill down. And you could see it's slightly more involved. So there are 4 build steps. I build the Docker image. I pushed it to the registry. I configured my connectivity to the development cluster. And lastly, I performed the deployment. So let's confirm that deployment has succeeded. I'll connect to my cluster. And there is a pod running for a minute, so that looks about right.
So while it felt like an eternity while he was trying to find the build logs, it actually took less than 70 seconds for it to... It was already built by the time. We spent more time worrying about it than it actually took to get done.
Exactly. So let's try and repeat the process again. But this time, I will merge my development branch to master. we should produce a new type of deployment to the production.
So same deal, different branch, deploying to a different target now. Is that what's going to happen?
Exactly. So
Great.
I configure that if it's master, it should be good enough to go into production.
And it worked the first time, so it's going to work the second time.
Absolutely. That's
Great.
how demos work, right?
Yep.
Let's give it a second. And now it's ready. So let's see if I can lose it again. No, I didn't. OK, so I click for the very last time on this yellow circle, go all the way to the Google Cloud build. And it looks pretty similar to what you just seen for the development. However, we're now connecting to a production cluster, and we're deploying to the production. So let's give it a few seconds. It has succeeded. So let's see the results. I'm going to stop this, connect to my production, and look for the pods. And
Dmitri?
look for the pods.
There's nothing there. Demo gods again?
Not this time.
OK.
If we go to the workloads of the Kubernetes engine, you can find it here. Refresh the page. I got two news for you, Michael.
Uh-oh.
It's good news and the bad news.
Good news first, please.
Remember the development deployment?
Yeah?
It definitely works.
OK. Bad news?
Production, not so much.
What's
So
wrong?
you could see that there is a development cluster, which is successful in Nginx deployment, but production, not so much. It looks like a long piece of text, but what we really care about is this. I have enabled a binary authorization on my production cluster because I don't trust anyone to deploy images there without additional authorization. But I've just attempted to deploy image there myself using a tag. The problem with the tag and Docker ecosystem is that they're not immutable. Therefore, I can assign the very same tag to very different binaries. And if you want to attest the binary deployed to your cluster, you need to be very certain that you're deploying some specific version. And the only way you can do this is to use SHA.
OK.
So let's
fix
try
it,
and
right?
fix it. I hope so.
OK.
I'm going to stop this.
So this end-to-end provenance, being able to know that what is running in production is exactly what was produced from this container, which was produced from this revision of the source code, is a really key principle that I would encourage you all to just work your way through. And it pays off over and over again when something goes wrong later on. You're trying to figure out what happened and where. So
Exactly.
explain the policy stuff to now? Yeah?
I will. So
Okay.
as you could see, the deployment did go through. And now I want to explain you the reason why. I had enabled a binary authorization policy on my entire project. I'm going to export it here so you can just see it in plain text. There's quite a bit of YAML, but you only care about two main parts. First of all, that there is a per cluster rules defined here. For the development cluster, I have a very loose rule saying always allow, which is pretty much a default G-key cluster rule. But for my production, I decided to crank up security, and I've added a QA attester policy. So there is a need for additional attestation of the deployment before they can happen to my cluster.
You've also whitelisted certain registries so that only those things can go. Is that right?
Exactly. So it's the most basic security principle you can apply. As you could see, only Google Trusted and my own registry allowed for images to deploy to my cluster. So you just can't go to a Docker Hub or Quay.io and deploy any random image into it. That itself provides unprecedented level of security because there are no more rogue deployments happening to your clusters. That's all good. So let's try and fix the mess we just made. I'm going to delete existing Nginx deployment and recreate it. As you could see, there is much longer command that I'm running because I'm using SHA. So it starts here, and then it's a full, unique, immutable binary signature of my Docker image. Let's deploy that. OK? So
It's going to work, right?
Yeah, we probably can go home.
OK, good. No pressure.
Not so much, Michael, not so much.
Uh-oh.
So we failed again. Remember?
This is like every part of my coding lifestyle. I write something, I fix one thing, it's still broken, lather, rinse, repeat. Hours go by.
Iterative development.
Yeah, iterative debugging.
So as I mentioned, I enforced a QA attester on my cluster. So there's a need for dedicated validation that has nobody provided yet. And when I refresh the message, it has changed now. And it says exactly that the trusted attester has not verified this image. What it really means is that there is a special metadata that you can associate with your image in a registry, which can only be produced if you have access to the attestations and you have access to the secure KMS. Therefore, no other person but me, because I'm the only person with the permissions, can create such an attestation. This could be automated and be part of your regular build pipelines. Imagine if vulnerabilities that we found earlier, we can create attestations saying that there are no vulnerabilities, and only if this attestation is in place, you can perform deployment. Otherwise, forbid them and make it impossible for them to go through.
So binary authorization essentially is acting as a gatekeeper, checking policy, but you actually determine how to set that policy through the metadata of your container. And you choose what settings you care about, what policies you want, and then binary authorization just asks, do you have the key or not? And so this QA person is going to say, I am the QA tester and I approve this container. Is that
exactly? And you can have 100 steps on this pipeline. So it's up to you to decide on complexity and type of validations. And obviously, it could be full groups of people, so it shouldn't be one person.
Right.
It's just an example here.
So the keys to that particular pipeline are the keys to the kingdom, and you keep them locked up in a tight place.
Exactly.
Great. OK, let's try it again.
Let's fix the mess. Take 2. I'm going to delete deployment once again, start from scratch. This time, I will perform an attestation, and I'll use credentials assigned to my user to sign up the very same image that I've tried to deploy a couple of minutes ago. As you can see, the SHA is the same. So it's the very same image. It takes a second. And now I'll try and deploy it again. Once again, it's the very same SHA, so there is no substitution happening. It's all the very same image. I've now deployed it. Let's see.
Look at that.
And that's great.
3 seconds ago, right away. Nicely done. The round of applause for Dmitri there. Come on.
Let's go back to the slides.
Very cool. All right. So we're going to switch to the next slide. So you showed us the demo. You told us the sort of nightmares before. Tell us about the life at Love Holidays now. How does it work out?
It's going a lot much better compared to the days of on-prem and compared to the days of Jenkins. So if you look at the diagrams, they got simplified a lot. Teams manage their own builds. They decide how many build pipelines they want for what stuff. I really don't care. So my only job is to tell them there are tools available, a rough guidance how to use them, and maybe provide a common build steps that the entire company can use. But it's their ultimate choice to decide what they do, because there is scale available from the Google Cloud Build that allows to build all the images at any time. Now can perform builds on every single branch and every single commit without worrying and making my developers go to some UI and click the build commands. It just kills the flow. You want everything built all the time. You want to get your release velocity improved because of that.
So instead of being the bottleneck, both in terms of the machines that were doing the builds and you as being the person who maintained those builds, you've essentially parallelized this, and every team can go off, build their own build process, spin it up, and you spend your time...
I won't tell you.
OK.
Definitely not doing builds. So release velocity within the company has improved dramatically. Because of the build everything, we're shifting the feedback to the left. We're also now deploying a lot more because we're using Kubernetes. We no longer need to make a serial deployments to our on-prem environments. We deploy everything at once. And we use auto-scaling and deployment resources in Kubernetes to make sure that we don't fall over while we're doing so. Lastly, the security has improved dramatically as well. We're using a very granular IAM policies and the service accounts of a Google Cloud Build to allow it very specific tasks in the building and storing created Docker images. We're using GitHub as an audit trail of all our builds and deployments, and therefore it's a united tool where you put the declarative build pipeline and the actual source code changes together. So you never have a doubt that they've ever been out of sync. They're always in sync. We use binary attestation as a last resort solution to catch images that were not meant to be deployed. And even the most simplistic use case where I whitelist the registry allows me to filter out 99% of the risk out there, because it's really hard to put something in my registry, and it's very easy to deploy something from other registries without binary authorization.
So this is really cool. Tell us how it's actually changed your, going back to the business goal of velocity and developer productivity. Tell us a little bit about that.
We've been really busy, and in the last year, we spent over 10 million minutes building our applications across all the branches, all the repositories. At the same time, we've grown the number of applications we actually develop, and we've grown our development team from about 20 to 50 people. So as a company, we've grown. Surprisingly, the release velocity that we have has also reached a record high. We're now performing about 50 production changes a day and about 150 non-production changes, so development, staging, etc. So we haven't done better than this before.
That's great. So contrary to expectations, you've added more developers, added more source, added more projects, and you've actually increased velocity and reduced complexity every step of the way.
We're scaling sublinearly.
That's pretty awesome. So Cloud Build is a key part of our CI/CD solutions. We're very proud of it. Other people seem to think it's working pretty well as well. If you want to find out more about just sort of the evaluations of cloud CI systems and so forth, the bit.ly link at the end is a great place to go and follow. I'll leave it up on the second for the thousands of pictures being to our hundreds or tens of pictures. I'd like to sort of just bring it into a close here. We talked about the rise of cloud-native applications and what it means to be cloud-native. We talked about how cloud-native principles apply to your software development and how you can take advantage of it and not just be in a lift and shift, not getting the velocity, not getting the benefits, just moving your data centers around kind of mindset. We talked about how those principles apply in a cloud, in a CI/CD environment, and how to let your CI/CD environment give you the velocity that you want when you're moving to the cloud. We talked about how Cloud Build provides security, scalability, and is simple to go off and spin up everywhere you need in your environment, so there's no friction to doing all the right practices. And hopefully at this point in time, you can now take what you've learned, which you'll remember basically about this much. If I remember anything, it's the same way. But remember to go and just take a stab at this, set up your own Cloud Build environment, literally by just creating a repo, putting a Cloud Build.yaml file into it. Believe it or not, you can even just point it at a repo with a Docker file in it. If there's no Cloud Build.yaml, we'll find a Docker file and we'll build that for you. So a great way to get started, just spin it up and try it out. And then hopefully you can start incrementally making changes to your build environment and take advantage of all the performance, all the simplicity, and the security that we can give you. So with that, I'd like to thank Dmitri for coming with us today. It's been really great. And thank you all for staying as late in the day as possible in one of the last sessions. And we'll be around for questions. But again, thank you very much.
Thank you.